So good afternoon, students. So today we will start with our one of the fundamental chapters of chemistry. We call that chapter as basic concept of chemistry. Okay. So I know that you students have completed your 10th standard and now you are moving to your 11th standard. And when you step to the 11th standard, you will see a different, I could say, a different approach for studies actually. So talking about chemistry, I could say we will classify the whole chemistry into three, that is the physical chemistry and the inorganic chemistry and finally our organic chemistry. So the first chapter we are going to deal with is a part of physical chemistry, that is as I have told, some basic concepts of chemistry. Okay, some basic concepts of chemistry. Okay, now, so what are the topics you need to learn in this chapter? So I can say this forms a fundamental for the physical chemistry, because this will give you an idea regarding what and all you need to understand with respect to physical chemistry. For example, how to do the calculations, and if you are doing the calculations, how the units should be expressed and all those things. So before I start with the contents of the chapter, I would like to introduce or do a minor revision on the basics of very fundamentals of chemistry. Okay, so here I am starting with the concept called matter. So everybody might have heard this term matter many number of times in different occasions. So you know, matter is something that occupies space. Okay, so we say what matter is made up of. We still have the answer. We say it is made up of small particles, and next question is what this small particle is made up of. So if you go dig like that, we say at the end of the day the fundamental unit of matter is an atom. Correct. So fundamental unit, we say it is atom. Now what an atom consists of basically? So we used to say an atom have mainly something called a nucleus. Okay, something called a nucleus, and there is something called electrons revolving around the orbits. So we say electrons which are revolving around the orbits, and we have a nucleus. So this nucleus have some particle which we call it as N and P, and the electron which will be revolving around the nucleus. So this is the fundamental thing that you might be knowing already. So we know atom has nucleus which consists of neutrons and protons and electrons revolving around it. Now we need to say, okay, how many atoms are present in a matter? So this is a difficult question to answer, because we don't know the matter size or its weight, nothing we don't know. So this chapter basically deals with the calculations like this. So we know in chemistry we have many different types of elements are there. So we have a big periodic table out there. So the whole periodic table is classified into 3, or we can say exactly 4. Okay, so we have one part where you have you could say the period 1 and we could say the group 1 and 2, which forms the alkali and alkaline earth metals. Okay, then you have, we say that is commonly called as S block elements. Then we have something called D and F block elements, and finally we have the P block elements. And it is estimated like the 78% of the elements are mainly metals and the remaining are non-metals. So a big question now come to your mind. Elements, a broad classification. Elements, we have a broad classification like elements. We have a broad classification like metals and non-metals. So I told metals constitute around 78%, and non-metals you could see it is, I could not say exactly 22%. There can be metalloids. There is a third classification. So I may say some 20%. And we have the third classification that is called metalloids. Okay, that means a metalloid could behave both as a metal as well as a non-metal. So that constitute around, as you could see, 2%. Now the next question again, we are going inside. We understood an element also consists of, element is also a matter, or element also consists of the fundamental unit as the atom only. Okay, so this atom will also have inside we see nucleus, and it has outside electrons. So all these things are made up of the fundamental unit called atom. Okay, now what we need to understand is what is a metal, just a fair idea. So a metal is somebody or a species, or it can be anything which is capable of donating electrons. Please understand, it is donating electrons. Okay, so and non-metals is something which is capable of accepting electrons. So very simple, metals are capable of donating the electrons what it has, and non-metals are capable of accepting the electrons. And metalloids, they share the electrons. They share the electrons with other elements. Okay, so I hope you got a bare minimal idea. Now we will understand, okay, so from where these electrons are getting donated, that is very important. So this is getting donated from valence shell. So a big question is coming here, what is valence shell? So we need to answer all these questions. So valence shell and those concepts I will be touching it, but that will be coming more specifically under a chapter called atomic structure. Okay, so here also the same answer from, I could say, valence shell. Okay, so here also the same thing, from valence shell. Fine. Now I have given you a little bit idea on what elements, how the elements are classified, broadly classified. And I told in the periodic table it is classified into S block, P block, D and F block elements. Okay, fine. Now coming again back to this chapter. Okay, now also one more thing I need to say. I told electrons are there. So whether electron has a charge? Yes. Electron is a charged particle. It is a charged particle. Okay. So electron, it is a charged particle. So what is its charge? Next question. So its charge is 1.6 into 10 power minus 19 Coulomb. Okay, Coulomb is the unit of charge. Okay, now, okay, if the electron has a charge and it is revolving around the orbits, you know that, and this value also you should understand, this is negative. It's a negative charge. Now you could understand that. So negative charge is revolving, so the nucleus definitely has a charge opposite to this. Okay, then only this will get neutralized, and we can say the fundamental sentence or fundamental understanding, atom as a whole is neutral. Very, very important statement. Atom as a whole is neutral. So for this neutrality, or for this atom to be neutral, we told the nucleus should hold a positive charge. So we know that nucleus consists of two things, correct? So we have one is called neutrons, and this is, as the term means, neutral, that is no charge. Then who hold the positive charge? I can say here, I could remove this or it will create confusion. So I can say the nucleus have neutrons, and the nucleus also have something called protons. So this proton is positive charge. So what is the charge? Next question. So its charge, we know it is neutral. So surely what it should do, this minus 1.6, it should have the same magnitude, but the sign should be opposite, so that it will get cancelled and you will get a neutral atom. So its charge should be plus 1.6 into 10 power minus 19 coulomb. So I hope you understood. Now next, what is the okay, so we know now what is a charge and those things. Now I am going to introduce a new concept. So that is called mole concept. So I should tell you, before I go to mole concept, what is basically a mole. Okay, so I will give the introduction, or the heading as mole. So we are going to learn a new term, that is mole. Okay, so I hope everybody might have heard this term mole in a different context, but coming to chemistry, this term has totally a different meaning. So how I am going to introduce this concept? I am not going to start very fast. I just will give you a fair idea with a different example. How many of you have heard the term dozen? DO is a DN, dozen. Most of you might have heard. So we know, whenever we heard the term dozen, what will come to your mind? I am sure a value of 12 will come to your mind, correct? Okay, so if somebody says I have a dozen pen, so what does that mean? So I could understand that he have 12 pens. Okay, if somebody say I have dozen pencils, then that means he have 12 pencils. So what is common in these two statements? You could understand that dozen can be used along with pen as well as pencils, but the numerical value or the magnitude value, the numerical value 12 still remains the same. Okay, so I want to compare the same concept over here also. So here, instead of dozen, I am going to replace that with a term called mole. Okay, so mole is nothing but my number 6.023 into 10 power 23. No additions, nothing. 6.023 into 10 power 23, nothing else. Now, what this number is called? And this number is called Avogadro's number. Avogadro's number. So how this is represented? Every time is it possible to write a whole number like this? No, of course no. So we could represent this using a much simpler convention, that is called Na. So Avogadro's number. This is what it means actually. Now we will try to put this term in different ways. So example, I am going to give some example. So if I am going to say that you have 1 mole electrons, what does that mean? So if I write 1 mole electrons. So what does this mean? This means you have 6.023 into 10 power 23. Can I stop here? No, sure. You please remember the examples of pencils and pen. Now I have electrons with me. So I can write electrons. Okay, I will put a small symbol like this, electrons. Okay, I can even represent this, you represent this like this also. Na electrons. Okay, another representation. Now you are somebody else is saying another example. So this is example 1. So this is example 2. So if somebody is giving an example like example 2, like I have 1 mole neutrons. One mole neutrons. So tell me, what does this mean? Again, it means the same. 6.023 into 10 power 23. Can I write electrons here? Of course not. You need to write what is the things you are representing. 1 mole of what? Neutrons. So I can say neutrons. Neutrons. Okay. So again, this can be represented like Na neutrons. Clear? So similarly, I could write as many examples as possible. So that means, very simple conclusion, 1 mole can be associated with anything, but the value of 1 mole always remains the same. So if I say 1 mole electrons, it means 6.023 into 10 power 23 electrons. If I say 1 mole neutrons, means 6.023 into 10 power 23 neutrons. And if I say 1 mole protons, it means 6.023 into 10 power 23 protons. Okay. It can be other than this also, as I have introduced you the term atom. Okay. If somebody says an atom, an example for an atom, hydrogen atom. If I say I have 1 mole hydrogen atom, what does that mean then? I have 6.023 into 10 power 23 hydrogen atoms. Okay. And if somebody says I have 3 mole of, okay, please one more time, 3 mole of magnesium atoms. So what does that mean? That means 3 into 3 times, 3 mole means 3 times. So 3 into 6.023 into 10 power 23 magnesium atoms. Okay, hope you understood. Now I have introduced the term atom, that means the fundamental particle of a matter. Now I can say there are, as I told, there are many elements in the periodic table, but every elements have a stable form. Okay, then a big question is coming, a new term I am introducing. The term is stable or stability. I could say the whole chemistry is based on stability. That term has a lot of meaning. A lot of perspectives are there. The term stability, even we know, right? So we say we are stable. So that stability in terms of many things. It can be mental stability, or it can be financial stability, or it can be, what you say, family stability, or that, based on the context, this has different meaning. Okay. Similarly, the term stability has a vast or a good amount of meaning in chemistry. Okay. So the next term I want to introduce to you is stability. So the term stability, stable or stability, it is more correct with respect to chemistry. So coming to chemistry, I will already discuss stability with respect to chemistry. Okay, don't worry. So here, stability with respect to chemistry is stability with respect to elements, because we know that all matter in this world or universe is made up of elements, correct? That elements, which we say each element, if you go inside, you can say the fundamental particle, again it is atom. Okay, so how an element or an atom can be stable? Big question, how to understand that. So I can say there are many rules are there. So the standard rules you might have learned is octet rule. Octet rule. Next one was duplet. Duplet rule. Okay. The term octet rule means very simple. If you have 8 electrons in your valence shell, so I want to introduce the term shell also, right? I will introduce, wait. So just now, just listen, just understand, if you have 8 electrons, so I will write here 8 electrons, where in valence shell. Valence shell, we can say that element is following the octet rule and that particular element is stable. Okay, so there are elements which does not follow what we call as the octet rule. They follow some, for example, hydrogen. It follows something, a different rule, which is called a duplet rule. So as per duplet rule, it states that if the element has 2 electrons in the valence shell, then that particular element is stable. So here it is 2 electrons in valence shell. Okay, now I want to introduce the term shell. Okay, so for that, let me tell, okay, what is the basic fundamental structure of an atom. So that is a big chapter. It's again a new chapter. So we are not going to define exactly the structure of the atom. We are going to introduce, to understand the concept of shell, we are going to give you a rough idea on the structure of the atom. Okay, listen. Okay, so as I have told, the fundamental unit, again, it is nucleus. Okay, the nucleus has neutron and proton. So I will put an arrow and say this is my nucleus. So here I am going to depict an atom. So you can ask questions, sir, this is the atom of which element? You could ask. Okay, it can be the atom of any element, finally, because all elements, they differ in the number of the electrons and protons. Okay, so currently I am taking hydrogen as element, hydrogen and its atom. Okay, so hydrogen, what is the atomic number of hydrogen? New terms are coming. Okay, hydrogen, the atomic number is 1. Okay, hydrogen, the atomic number is 1. What does that mean? You might have learned in your lower classes. So atomic number is 1 means the number of protons is equal to 1. Also it means the number of neutrons, I will tell what it is, and number of electrons is 1. Okay, then how will you calculate the number of neutrons? The number of neutrons is calculated as, you might be knowing the mass number. Okay, the mass number of hydrogen, and you could also calculate from the mass number, you could subtract it and get the value. Okay, so we will hold this. Wait, we will first introduce the concept of this. So as I told, we have a nucleus out there. Nucleus, this is, I told, nucleus of hydrogen atom, and I'm telling around this nucleus we have what is called the shell. It is called the shell, or the other name is orbit. Okay, so we have different types of orbits or shell. We say the fundamental thing as K shell, L shell, M shell, N shell, KLM. So also you might have, okay, we next need to introduce how much electrons a K shell can hold. And what is valence shell? Valence shell is the last shell or the final shell. So here for the hydrogen atom, as you know, the atomic number is 1, so the number of electrons is 1. So what is happening there? Okay, so in that case, here the only one shell is required because only one electron is there. So I could say that one electron is revolving around the nucleus like this. Okay, so this is also my valence shell for the hydrogen atom. So right now you might have understood what is shell means or orbit means. There are many other terms are there, subshells, orbitals. So those things we will go in detail in atomic structure. This now you should understand the revolving electrons are revolving something called an orbit or a shell, and the final shell. So for hydrogen atom there is only one shell. Suppose if it is oxygen atom means you need to write more shells to accommodate more electrons. So the final shell is called my valence shell, and only that shell, okay, is capable of losing the electron or gaining the electron. Okay, we will understand that why it is like that in more detail in a chapter called classification of elements and periodicity in properties. Okay, so I have introduced okay, I didn't answer for your question, number of neutrons. So the number of neutrons here is 0. Mass number minus the number of protons will give you the number of neutrons. So here the hydrogen, the mass is 1, so the number of protons is 1, so 1 minus 1, you will get a value 0. Okay, now I have introduced you the fundamental terms. What is mole I have told. Now I am going to introduce a new term that is called molecule. Okay, what is the term? Molecule. So, okay, I will use it. Okay, so molecule, how molecule came into picture all of a sudden. Okay, so as I told, I was talking about elements and I was talking about stability. Okay, now you have some fair idea regarding stability. So I told some elements can exist, okay, in different stable forms. Some elements may exist as an atom. Atom means the fundamental unit. And for some elements, they may not exist as an atom because it may not be the stable form. You know, to get its stability, 8 electrons or 2 electrons it will try to attract. So what it will do, for example, hydrogen atom like species, as you know, it will follow duplet rule. But each hydrogen atom has only 1 electron, correct? So what it should do, it will share one more electron with other hydrogen atom. So something like this. This is my nucleus of the first hydrogen atom, and this is my shell. This is my first hydrogen atom, and you have a second hydrogen atom out here, so that will also have an electron. Now what this will do is it will share the electrons in such a way that this hydrogen atom and this hydrogen atom combine together. So this is a hydrogen atom and this is also a hydrogen atom. So they will combine together to form H2, a new term, atom combining to form a new term that is called my molecule. Okay, so I hope you are understanding what is the term molecule means. Fine. So why it has combined? Now you have an answer. It has combined to attain stability. Okay, why it is stable? It is following duplet rule. Okay.